In 2017, a spacecraft fell into Saturn on purpose. It wasn't an accident, it was an execution. For 13 years, Cassini circled a world wrapped in light. Then it aimed itself downward and burned. The last signal held steady until the atmosphere tore it away. Saturn wears the aftermath. Those rings look delicate. They aren't. They stretch nearly 300,000 kilometers wide, almost the distance from Earth to the Moon. Yet in some places they're only about 10 meters thick, as thin as a small building, spread across a planet large enough to swallow more than 700 Earths. That contrast should bother you. We were taught to see Saturn's rings as decoration, a cosmic crown, a frozen halo placed there at birth. But Cassini didn't see jewelry. It saw debris, countless shards of ice and rock orbiting at highway speeds, colliding, fracturing, rearranging in a silent grind that never stops, a shimmering disk built from impact after impact after impact. Beauty isn't always peace. Sunlight hits the rings and explodes into brilliance, scattering off billions of icy fragments like shattered mirrors suspended in vacuum. But inside that glow, gravity pulls, objects smash, momentum transfers, and something is constantly being lost. If this is a crown, it's made of wreckage, and wreckage means something was destroyed. Cassini went there to read the evidence. It came back with numbers, particles, measurements, receipts. Because if the rings are debris, then the real question isn't how beautiful they are. It's what they erased. The rings are not solid. They are traffic. Billions of ice fragments orbit Saturn at tens of thousands of miles per hour, each piece following gravity's script, each collision rewriting it. From a distance, it looks smooth. Up close, it's chaos layered into order. We expected a quiet halo. We found a grinder. The ring system spans about 300,000 kilometers across. That's nearly Earth to the Moon, stretched flat into a disk. Yet in many regions, the thickness is only around 10 meters. A structure wider than a planet's shadow, thinner than a city block is tall. That imbalance is the first warning. Inside the rings, particles range from dust grains to chunks the size of houses. They slam, shatter, clump, and break apart again, guided by Saturn's gravity and the subtle tugs of its moons, which act like shepherds, carving gaps and sculpting sharp edges into what should have been a blur. It's a construction site powered by destruction. Sunlight turns the ice bright white, but that brightness hides motion so violent it would tear apart any spacecraft drifting unshielded through the lanes, where even a fist-sized fragment carries the force of a speeding car with nowhere to brake. Beauty can be a massacre in slow motion. And here's the unease. Structures this thin don't last forever. Gravity doesn't allow it. Momentum bleeds away. Material migrates. Something is feeding Saturn. The glow isn't static. It's evolving. Then there's the scar. At Saturn's north pole, the clouds don't swirl randomly. They lock into a shape, a perfect hexagon. 6 sides, sharp edges, miles above chaos. The hexagon is a massive jet stream, a storm system circling the pole at hundreds of miles per hour. Each side of that 6-sided boundary stretches longer than the diameter of Earth. You could drop our entire planet inside that shape and still have room along the edges. It has been there for decades. First seen by Voyager in the 1980s. Still there when Cassini arrived. Still there when it died. A planet with an edge. We expected turbulence. We found geometry. The hexagon isn't a solid wall. It's wind. A river of atmosphere moving so fast and so precisely that it folds into a stable polygon, like fluid trapped in an invisible mold, holding its angles while Saturn rotates beneath it in 10.5 hours faster than any planet that size has a right to spin. That speed matters. Rapid rotation stretches Saturn at the equator and compresses its poles. The planet bulges, the winds accelerate, energy distributes itself with ruthless efficiency. The hexagon is not decoration, it's a symptom, a visible boundary where forces balance so perfectly that chaos becomes structure, and structure becomes permanent enough to feel intentional, even though it's nothing more than physics repeating itself. If the sky can carve straight lines out of gas, then Saturn isn't just wearing debris, it's running a system. And systems don't hide damage, they process it. Saturn doesn't stay quiet. Roughly every 29 to 30 years, the planet erupts. It's called the Great White Spot, a storm so vast it wraps around the entire globe, turning calm beige bands into a boiling scar of white that can outshine everything around it, as if the atmosphere itself has decided to surface what it's been hiding. One Saturn year is about 29 Earth years. So this isn't random, it's seasonal. We expected slow, distant weather. Saturn keeps appointments with chaos. These planet-wide storms are driven by heat rising from deep inside, energy stored for decades before punching through the upper clouds. Imagine pressure building beneath a sealed lid for 30 years, then splitting it open in weeks. Lightning flashes inside these storms. Winds accelerate, cloud layers mix violently. Every 30 years, Saturn loses control. But it's not losing control, it's redistributing energy. Saturn radiates more heat than it receives from the Sunday. That internal heat fuels the atmosphere, feeding cycles that repeat with clock-like patience, proving that beneath the pale exterior is a planet constantly rebalancing itself, shifting mass and motion in ways we only partially understand. And here's the tension. If storms this powerful are routine, then Saturn's surface is never stable for long. Material rises, material sinks, chemistry changes. Nothing just sits there. Not the clouds, not the winds, not the rings above them. And when a world keeps cycling energy like that, you have to ask where the excess goes. Then there's Titan. From orbit, it looks soft, orange, calm. It isn't. Titan's atmosphere presses at about 1.5 times Earth's surface pressure, thicker air, heavier sky. If you stood there, the weight above you would feel familiar but denser, like breathing through a world that doesn't quite trust you. And it rains. Not water, methane, ethane. Rivers cut through ice. Lakes pool across the surface. Clouds gather and fall in cycles that look eerily terrestrial, except the temperature hovers around -290 degrees Fahrenheit, cold enough to freeze rock solid and turn water into bedrock. A world that looks like Earth poisoned. We expected a frozen rock. We found weather. Cassini flew past Titan again and again, mapping its seas and probing its chemistry. Radar pierced the haze. Spectrometers tasted the air. Organic molecules drifted through that thick atmosphere. Complex carbon chains forming in the upper layers and settling down like dark snow. And then came the twist. There's growing evidence the rings might be younger than Saturn itself. Not ancient relics from the planet's birth, but debris from something torn apart later. A moon, perhaps, shredded by gravity, recycled into brilliance. If that's true, Saturn didn't inherit its crown. It made it. The rings might be younger than the planet. That changes everything. Because if the rings are recent, then whatever was destroyed wasn't primordial dust. It was something structured, something close. Enceladus shouldn't matter. It's small, barely 300 miles wide, just another icy moon. Then it started leaking. From fractures near its south pole, towering plumes of water vapor and ice blast into space, spraying material hundreds of miles above the surface, like a cracked artery venting into vacuum. Cassini flew through those plumes. It tasted them. What it found was not just ice, water, salt, organic compounds. It wasn't just ice, it was ingredients. Inside Enceladus, beneath miles of frozen crust, gravity and tidal forces from Saturn knead the interior, generating heat the way you warm your hands by rubbing them together. That heat keeps a global ocean liquid under the shell, a hidden sea, locked in darkness, pushing upward through fissures. We expected a dead snowball. We found chemistry. The salt in those plumes suggests contact with rock below, water interacting with a rocky core. That's the kind of environment that, on Earth, feeds entire ecosystems near deep-sea vents without sunlight, energy from chemistry alone. Let that sink in. An ocean world, orbiting inside a debris field, under the shadow of a gas giant. And suddenly, The rings aren't just wreckage, they're a contamination risk. If a moon like this might host the raw materials for life, then anything we send there carries consequences. A single microbe from Earth could rewrite that ocean's story forever. Which is why Cassini's mission was never going to end gently. It was always heading toward a choice. Cassini knew too much. After 13 years in orbit, it had mapped the rings, skimmed Titan's haze, and flown through the frozen breath of Enceladus. It carried Earth's microbes on its metal skin, invisible, uninvited. That became the problem. If Titan has lakes of methane and Enceladus hides a salt ocean, then crashing an aging spacecraft onto either world would risk contaminating environments that might already be chemically alive. Even a single surviving bacterium could confuse every future measurement. So the decision was made. In 2017, Cassini aimed for Saturn. No rescue, no rewind. During its final orbits, it dove between the planet and the inner edge of the rings, slipping through a gap only about 1,200 miles wide, narrow on a planetary scale, threading a corridor of gravity and radiation where no spacecraft had ever flown, measuring particles and magnetic fields as if gathering last statements from a crime scene. Then came the descent. It kept its high-gain antenna locked on Earth. Data streamed back across nearly 1 billion miles. Even as the atmosphere thickened, even as drag built, even as the spacecraft began to tumble under forces no engineer could counter. Physics is not sentimental. Friction heated the structure, plasma formed, signals flickered, and then silence. Cassini died to keep other worlds clean. But before it burned, it confirmed something unsettling. The rings were shedding material into Saturn's atmosphere, a slow rain of ice and dust. The evidence wasn't static. It was disappearing. The rings are not permanent. They are falling. Cassini measured streams of icy particles spiraling down along Saturn's magnetic field lines, a phenomenon scientists call ring rain. Material from the rings drifts inward, vaporizes, and becomes part of the planet's upper atmosphere. Saturn is eating its own evidence. Current estimates suggest the rings could disappear in around 100 million years. That sounds vast. It isn't. Saturn is over 4 billion years old. On that scale, 100 million years is a brief chapter, a blink stretched across cosmic time. We're watching Saturn's crown evaporate. If the rings are younger than the planet, and they are already fading, then we are living in a narrow window, a rare epoch when Saturn still wears the debris of whatever it destroyed. Beauty with an expiration date. Gravity never rests. It redistributes. It pulls, sorts, and recycles matter until structures collapse or transform. That same principle shapes galaxies. It shapes atmospheres. It shapes Earth's own delicate balance between radiation and magnetic shielding, between climate stability and chaos. Nothing this intricate is static. Not Saturn, not its moons, not us. The rings shimmer because countless fragments are grinding and migrating, each orbit slightly imperfect, each collision stealing momentum, each year thinning the system by fractions too small to see but large enough to matter over millions of years. Saturn's beauty isn't decoration, it's destruction caught in orbit. And one day, the sky around that planet will be empty. The question is, what else will be?